Going to just, I guess, it's very difficult to cover off a flora of a region in 45 minutes. So I'm going to try and boil it down and give you some of the high-level principles and key points. Because as we'll see on one of the slides a little bit later, there are at least 500 species of vascular plants in the Hawke's Bay region. And it sounds rather daunting, you know, if you had to learn them all, but I've often told people that the way to do it is to try and learn five a day and just keep going. So you can do the calculations on how many years it would take you. Actually, it's not too long, really, is it? 2 or 3 years, you should have been able to learn all of the 500 species. And particularly if you've learned some of the clues about how they relate to each other, because once you've seen one member of a genus, you can start picking up and understanding what the others are. You'll notice the bias in our talk today immediately on the first slide, because Catherine being an epiphyte expert, we just had to put an epiphyte on the front page. But this leads me on to a significant point about the Hawke's Bay flora. Because of the comparatively dry climate, and epiphytes are not as well developed as a part of the flora in the coastal and lowland zone as they are in other parts of the country. So the big thing about Hawke's Bay, if you think about the whole of Tigao Maui, as we were reminded yesterday, a proper name for the North Island, there was a very distinct pattern in terms of climate from the west to the east. And we sometimes talk about the windward side, which is the west coast of North Island, and the leeward side, which is the east. And there's a massive rainfall gradient from west to east. So some of the rainfalls here over on the east are as low as 800 millimetres a year, which is a very low rainfall. Where I was raised in Taranaki, the rainfall in the town where I lived was 2.5 metres, 2,500 millimetres, which meant it rained pretty well every day. And this is what we have to keep in our minds when we're considering the flora of the Hawke's Bay. And what I want to do here is not give you the full account of the 500 species, but tell you about some of the distinctive characteristics of the Hawke's Bay and how that will connect to restoration in particular. So that's the sort of where we're heading comment. And then what you need to do, depending on where you live in the Hawke's Bay, is to try and get familiar with your own backyard, you know, your own particular flora, the ones in your own backyard. Because the plants that are present on the landscape are determined by some broad scale patterns as well, not just by the climate, but particularly by altitude. How high are you up, you know, from the sea level, and also on the nature of the substrate, the parent materials that form the soil that the plants grow on. And you've got some classic gravelly rivers with also a braided river type, if you like, rather like some parts of the South Island. Alluvial systems, so like the Tuki Reserve, where you get the kahikatea and the tortura and the matai and all of those species. So I'm just going to show you a range of those habitat types to begin with before I start drilling down into some of the details of the species. And I'm not going to focus on the common species, because you've probably all encountered those, tortura and the matai and the reno and the kahikatea will be familiar to most of you. So here's this one here at Waipala, again showing that characteristic of the gravel and the sediment and the braided nature of the system. So those parent materials have a rather different flora than other types. You see the theme here. Here's a narrower system, English Bush Scenic Reserve, but again some of those key species like kahikatea are still there. And how many of you have been to Adines? This is a very diverse, this has got a very nice understory of some divarica plants that we're going to get onto a little bit later. Oh, Kay's right. Hello, Kay. So as I said, altitude and substrate are critical determinants of the flora that you would need to get to grips with. And here up on the range here, you can see the way the Nothofagus, the beech, clustering on some of the ridge tops, that very distinctively different forest type, the beech forest. So again, the substrate, the geology is critical And of course the classic thing for parts of Hawke's Bay is the presence of various forms of limestones and siltstones. You know, they're calcium rich. We call them calcicol is the general term for the substrate. They produce a very fertile but more alkaline type soil compared to some of the acidic soils where you have higher rainfalls and leaching occurs. So again, you know, you come back to that, what is the underlying substrate in your own local spot? Because that will largely determine the style of flora present. Sandstone, of course, is the other. Sandstone, siltstones, those sorts of things. And Tomato Peak, where you get the outcrops there of quite a lot of limestone involved there. And of course, right down by the ocean, you get that entirely different condition where you can get that interplay between salt and water and fresh water, and the water table which determines the composition of the estuarine vegetation, largely rushes and sedges, the main groups represented there. So just then focusing in on some of those distinct aspects of the Hawke's Bay flora compared to other parts of the country, sort of summarised here, at distinctive dry habitat parts of the coastal and lowland zone, rich in divaricating species. I'm going to get on and discuss those shortly. Rich in threatened species. That's a strange way to express it, isn't it? You don't really want to be rich in threatened species. You want to be depauperate in threatened species, but you do have a significant number of threatened species. I will say something a little bit about the mistletoes too, because you have some very interesting mistletoes in Hawke's Bay. Going back to that comment again about low in epiphytes because of the low rainfall and the low humidities in many parts of the district. So divaricating is really talking about the nature of the branching pattern of the shrubs. So shrubs that have small leaves and these very intertangled branchlets. We'll talk a little bit more about those shortly. Epiphytes, a reminder from yesterday, just the plants that perch on others, they don't have a parasitic relationship. They're just sitting on other plants. And what we've learned actually in recent years is that sometimes the epiphytes can be supplying things to the trees that they're growing on. That was the most amazing thing to find out, that some of the epiphytes that collect organic matter are actually allowing, because the branchlets of some of the big trees grow aerial roots, their aerial roots of the tree will grow into the epiphyte, and the epiphyte is actually helping the tree. So some of these things have only been found out in recent years. Mistletoe is hemiparasitic, so they take their nutrient and their water from their host, but they do photosynthesize. They are able to make their own starch, their own food, so they're green. So they're doing half the job, if you like, hemiparasitic. So we'll have a bit of a look at those too. I think that one is Coprosma fluorescens in the picture. So again, when you start getting into the flora, you sort of need to understand the categories of the flora, their life form or their taxonomic relationship. And here's a pie chart constructed from a species list that we did up in the Upper Waikura, a bit north of the Chinurako, on the edge there, a small area called Pigiri area. And you can see the different proportions of the different groups of plants that are found. And again, reminding you that we're only talking about the higher plants, the vascular plants. There's no data in here about mosses, lichens and liverworts. They're not in this pie chart. Basically from the ferns through to the flowering plants. And you can get a sense of, what are the really big important categories. And obviously with tree in a forest, clearly it's going to be largely around the gymnosperm trees and the dicotyledonous trees up here in this colour. A bigger category, dicot shrubs and what have you. And here again, just to give you a sense of the scale of what you're dealing with. it's more than 500 species in the whole of the Hawke's Bay, but in this one location in one river valley, 183 different vascular plants, you see. This is why I keep reiterating this point about when people do restoration, they often, and there are a range of reasons for this, they focus on a small number of plants they use at the beginning of the process, the pioneer plants. And because of limitations, sometimes with the nursery industry will only want to grow a certain number of species where they can get the economic return. We are not making use of the amount of diversity available to us on the landscape. And if we're going to have restoration planting which is able to be resilient to things like climate change and survive on the landscape in the longer term, we have to progressively start making more use of the wide range of species that are in our region. So I'm going to now talk a little bit about the ones that I see as an outsider, because I don't live here, but as an outsider, these are the ones that I think are, underestimated their value, or they are distinctive in terms of how the Hawke's Bay fits with the rest of the Northern Island. So species like Dioecious with its lovely tomentum on the back, that fur on the back of the leaf, which is an adaptation which helps it control water loss. So there's a clue often in the growth form, the morphology, and the physiology of the plant which tells you about why it's so successful on the landscape. So really densely covered underneath and on the stems and the new growing tips too, with a white furry. And that is a mechanism to protect it against water loss. Crassifolia, which has really almost slightly succulent leaves. It's actually trying to, first of all, it's got its stomata concentrated on the bottom side of the leaf, but it has a degree of waxiness and succulence again, which is adaptation to try and stop it losing its water. And just the mere fact of having small leaves is an adaptation to prevent water loss. Really wiry, strong little branchlets. And another characteristic for people like me who come from the western side of the North Island is we love to see the amount of Hawke angustifolia that you've got on your landscape. The lacebark, the narrow-leaved lacebark. Well, where I come from, we only have the large-leaved lacebarks, and this one is completely absent. And again, it's this interplay. This one has a divaricating juvenile and a non-divaricating adult, and again, it's really tuned in to the eastern dryish climates. And we're going to get to Dioecious, and that was a little note there for the future. We're going to get to that. So here we are, and again I'm coming back to what makes the flora over here distinctive. And this is in the upper Waikura Valley alone, 20 species of divaricating plant in one location. 11 of them are dicotyledon shrubs, 8 dicot trees, and 1 gymnosperm. Who knows what's the gymnosperm that's divaricating? The conifer, the native big tree that has a juvenile which is divaricating. Matai. And of course, small trees like the Kaipomaka Pinantia is really great on river flats for restoration projects. I guess again I'm coming back to this notion that lowest common denominator approach where you just use, the flaxes and the tikova, the cabbage tree and other things. There are many other things out there that are available that can be very useful in restoration by period planting. The kōwhai, of course, Sophora microphylla, with its very densely intertangled young form branchlets there. And as a juvenile it's like this, and as it gets to be an adult it starts to lose this characteristic. Strepilus, Flora, small leaf milk tree, that's another one of these divaricating plants. So just before we get on to there, of course there are the competing hypotheses about what caused this particularly distinctive growth form in our flora. And the two competing hypotheses, although they're not actually mutually exclusive, is that this may have been an adaptation to moa browsing. And then the other major hypothesis that people put forward usually is that the growth form itself is an adaptation to extreme climates, particularly dryish ones or frosty ones. And even in recent years there's been a series of publications coming out where people are debating backwards and forwards. Was it the moa? Was it the climate? Was it the moa? Was it the climate? You know, the point is they are not mutually exclusive hypotheses. And anybody who's studied a landscape will know that divarication certainly does give benefits in the face of browsing animals, including grazers and browsers like cattle and goats and sheep. But the moa, of course, did not browse the same way as those ungulates. That was a different way of browsing. Most people think that the moa sort of pushed his head in there and grabbed the intertangled branchlets and may have stripped foliage, may have, using the sharp beak, occasionally cut branchlets. But as people have done more and more study on the diet of moa and how did they do it, by examining moa crap that's been found preserved in caves, they find that actually their diet was way broader, way wider than just divaricating plants. And so that sort of takes some of the emphasis away from the moa browsing hypothesis. And in recent years, there's a guy at the Waikato University that works with us by the name of Chris Lusk, who's done some really fundamental work on the relationship between climate and the divaricating growth form. And of course has demonstrated that simple observation that I've already made quantitatively, numerically, mathematically, that simple observation I already made, that on the eastern side of the North Island in a dryish environment, there are way more divaricates than on the west. So that's a supporting observation for the climate hypothesis. It's more complex than that, and we'll find out about that a little bit further on in the talk. Now this is a table from a report that was published in 1998 by Jeff Walls, and of course the information in here is somewhat out of date now, but we put that as one of the links on our handout, the Jeff Walls report. I had the privilege of working with Jeff a couple of times down here in the Hawke's Bay when he was doing some of the protected natural area program surveys. And so I just think that little report, which is still easily findable by Google on the web, is a really good summary of some of the most interesting of the threatened plant species in the Hawke's Bay. So we're going to have a bit of a look at some model. Of course, this one I think is your premier plant. And we noticed at the Dole Bell Reserve yesterday that people were planting the Cleanthus. Of course, the Cleanthus does have quite a bit of variation in its populations from further up on the east coast up near Te Kaha, coming down into the Hawke's Bay, and you do need to be a little bit careful about where you get the material from. So the form known as Maximus, which is the really big giant Cleanthus, is more of a way north of here plant. Cleanthus is tuned often into substrates which have a significant amount of limestone in them. So some of the early records, particularly from up near Tūroto and up on the cliffs at Whakapunaki, were places that were well known to be where this plant grew naturally. It succumbed largely because of its great attractiveness to browsers. They just love the leaves of this plant. And why is that? Because Cleanthus is a member of the pea family, and it naturally is capable of fixing nitrogen in its roots, taking atmospheric nitrogen, turning it into the nitrate that is useful for plants, and its foliage is packed full of nitrogen, which is what browsing animals in particular need to survive. And so it's a key nutrient for them. And you will notice that snails and slugs and goats and everything go for this plant. This is the ice cream of their menu. Basically, they go for this one. Cleanthus, but it is spectacular, and I caught one and people also, of course, use that more English name, carpet pea family. And different flower colours too. So some of the ones up on Whakapunaki were originally collected were white. And of course the horticulturists got hold of these things too, and there were various pink forms that used to be grown in people's gardens, which were the cross between the red and the white to give you the pink. And fantastically, well, you know, really great. In recent years, some work done out of Forest Research Institute, Science, working with local iwi, reintroduced the white Kōwhai Mitukaka back onto the Whakapunaki area. And they did that because luckily people from way back had collected the seed in some of their herbarium specimens, and they were able to get hold of the seed, which was still viable, and grow the true white form that came from that location up as plants, and then reintroduce them back into the wild, at the same time as undertaking really good pest control, mainly the goats. That's also why the plant grew right out on the cliffs. You know, that was the last bit that the goats couldn't get to. So they would have been grown more widely than just on the cliff face prior to the arrival of goats. And the mistletoes, the lepus flava, the yellow mistletoe. So remembering that this is a hemi-parasite. Plants like Hector's tree daisy, olearia, and that also a threatened plant. It's a very small leaved, basically it's a small tree daisy. It's in the daisy family. And this one, how many people have seen the woodrose in the wild? Yeah. And of course this one was reduced somewhat because of the activities of collectors who used to go out and get the, you know, the wood part of the connection where the woodrose connected with its host, and then take the plant away and boil it up and remove the wood part and then use it as a decoration. You can still go into some old second-hand shops even these days and find stuff down the back of a room where people have collected these things in the past. And of course the other problem is its palatability, but also its reliance on our native bats for pollination. And as the numbers of bats have declined at times, this has an impact on the ability of the plant to successfully reproduce. I had to put this one in there because my photo's in it, obviously. But Pittosporum molcaudatum, I've had an obsession with Pittosporum molcaudatum since at least the 1990s. And that was caused because I was involved in some of the Protected Natural Areas program surveys up in the Tairapa, the East Coast, and also coming down here with Jeff Walls into the Hawke's Bay on some of my first visits. And Jeff Walls actually invited me over to the Hawke's Bay when he was doing his Protected Natural Areas surveys, because I got my eye in for this plant and I could spot it on a river flat. Actually, we did have a competition one day. We had a competition of about 4 or 5 botanists, Tony Bruce and myself and several other people, who could identify or spot Pittosporum molcaudatum at the greatest distance. I am happy to report I won that competition. It's approximately 200 metres. And when I mean how can you spot it, within a community of divaricating plants. So it's not, you know, it's not as simple as it might sound, but this incredible pattern, when you're looking down on the end and the branching pattern, the architecture of the whale, that's what I always looked for. I was looking for that pattern. It's a form of pattern recognition you have to be good at. Now, I'm going to later on tell you a bit more about that, so I haven't quite finished my session yet. So the mistletoes, Lindsay with a rather flattened structure, and it grows, its main hosts are divaricating plants. And here's again this repeating signal of the dryish climate. And so the divaricating plants, which are so good at coping with the dryish climate, these particular species tend to focus their attention on the divaricating plants because the divaricating plant will be the supplier of their nutrient and water, and they'll produce their own starch. And the other little one, the more cylindrical one, Salicornioides. This one I also have a bit of an obsession with because this was first found up by Wairo, and it was found originally by the family of the wife of Tony Druce. Have you heard the name Tony Druce, people? I'm sure some of you have. He was New Zealand's probably greatest ever field botanist, I think. I was privileged to meet him when I first joined the Department of Scientific and Industrial Research a long time ago. And so his wife was a Hodson, and they lived on a station up Wairau way. And they noticed, just as young children even, wandering around the station, that they had this koromiko growing on their station, which was somewhat different to the normal one. So it's got a sort of a yellowish midrib and quite a fleshy leaf, really, compared to the standard koromiko, which is heavy stricta. And so that's another one which it's through the Mahia Peninsula, and it sort of comes a little bit south of Wairau. I still think it may be lurking in some parts of the northern Hawke's Bay, where it hasn't yet been found, possibly. And of course, it was given the name to reflect the fact that it's got that eastern distribution. Okay, so now going into the issue of the epiphytes, this is a distribution map of Hawke, which is the Phytosporum cornifolium that grows right up in the trees, that was on our very first slide. And I just wanted to show you this map because it's one of the predictive models we use for understanding the distribution of species. So this map is based on some mathematical equations where you take mean annual temperature, mean annual precipitation, that's rainfall, evapotranspiration rates and stuff, and you take all of the data points that you have of places where you know, and notice that one's not quite right because it doesn't go in the sea, and you take that data and you prepare a mathematical model to make a predicted surface of where would you go looking to find it, and you can use that model to help basically inform your searching of the landscape. And so this is what I'm going to show you now, is how we use the model and tested whether the model was going to be possibly able to find a new location for this particular species. So I called it the Great Mahia Hunt for Phytosporum cornifolium. So here's the shrub growing on a tree, very distinctive. It grows up in big clumps of neck epiphytes, and the shrub hangs down. And so normally it's way up there, and so the long and short of it was we went to Mahia. It had never been recorded at Mahia, and we went searching through some of the forest patches there and went directly to some of the big old rimu, and sure enough, it was there, growing right up in the trees. So there's a photograph of it on the Mahia Peninsula, growing right high in the big rimu in one of the reserves. That was on the same tree but lower down. And there it is in its glory. It's a beautiful shrub. It's just finished flowering over our way. I think it's probably finished here. It usually flowers really early in October. It's a spring flower. And it's just got this amazing cluster of flowers on the end there. So Catherine will be satisfied with the talk today because I've been focusing a bit on epiphytes. And here's another one that's characteristic of the eastern side and comes into the Hawke's Bay, Coprosma pedicellata. This is again going back to that location in Waikura Valley. This is a meander in one of the rivers there, the Waikura stream or the Waikura River. And there used to be a bit of a lagoon in the foreground there, but in 1988, the date of the famous cyclone Ebola, the lagoon got completely filled with sediment. But this particular Coprosma, its specific habitat is on the edge of the river terrace and the meanders or oxbow lagoons in the rivers. And you can just see here, this photograph was taken to show that, just that little lip there of the edge of the alluvial flat. And if you want to go looking for this plant, that's where you look. It's really specific in its habitat. And give you an idea of the size that it will grow to, it's a small tree, basically, shrub or small tree. And this is the distinctive characteristic it has compared to other divaricating Coprosmas. You nick the bark, this fantastic orange colour. Most of the others do not have that deep orange colour. They might have a greenish hue or even a yellowish one, but they don't have the orange colour. And it was only recently named, given its name. Its scientific name. And pedicellata refers to the fact that it has little pedicels or stalks on it, so it looks like a grape hanging off. If you find a Coprosma with a little pedicel on it, odds are about 95% in your favour that it'll be this species, because most of the small leaf Coprosmas, first for a start, they don't have the black or violet colour, but they don't have the pedicel. They are sessile, they're completely connected to the branch without a little stalk. So, sort of getting into now about some of the reasons why some of these threatened plants have declined. This is some data that was collected on the population structure of Coprosma pedicellata. It shows on the axis here, the x-axis height class in metres. And you can see there's a bunch of plants down here at this height. Below here, the 1.49, there's a gap, nothing in here. And then you start getting the odd plant here above 3 metres in height. This is the classic population structure of a plant that's being heavily browsed. So when they're small, they're less visible, they're often hidden away in amongst the rushes and the sedges, and the browsing cattle, I'm talking about cattle here, don't really notice them. But once they get above a certain height, they get heavily browsed, and then when they're older and tall, once they've sort of done their escape of the browsing height, they survive. But the problem is, for the longer term, if that keeps happening, you're on your way to extinction, local extinction. So again, this is the sort of thing we do with this sort of data. This pretty well just shows the same thing, but it shows it probably more. This is the size of the stem of the individuals, and you can see here again there's a bit of a cluster down here of younger plants, but then you see the 3 metre height, right? That's basically the height at which they can no longer reach and strip the foliage off the small shrub or tree. So here's, in words, a mathematical model to predict how long a population of Coprosma pedicellata can survive on the landscape. So first of all, you have to have information like how long does the plant live? And the best way to do that with a woody plant is to find a dead plant and cut a disc from it and count the annual growth rates. And then if you get a whole bunch of those, you can actually build a little model of how age relates to diameter. And then you can use that data to make predictions about the age of different individuals in your population. We reckon on the basis of the data we collected that no Coprosma pedicellata ever lives to be about 100. It's quite a short-lived small tree. The oldest ever recorded one based on this sort of data is 85 years. So we've done calculations of the death rate. We've done calculations of the growth rate. And here we have this comparison. Remove browsing completely. They will grow 33 centimetres per year. And so the largest existing juvenile at this location would take only 5 years to reach adulthood. In other words, if you remove the browsing, you would save the thing really quickly. But if you do not remove the browsing, it's on the pathway to local extinction. So now I'm going to go back to my obsession with Pittosporum again. This is what Pittosporum occultatum looks like. This also is a bit of an indication of browsing. So normally, you should have foliage all the way down here. There's been a bit of browsing going on. This one also flowers in October. I'm not sure about the Hawke's Bay, but over Gisborne Way, I always used to go looking on about October the 15th. That was the date of knowing when would this tree be flowering. So it's a divaricating small tree, right? And it has the added problem, as does Coprosma pedicellata, of being, using this horrible technical term I'm going to use now, dioecious. Dioecious, which means separate individual plants are either male or female. Whereas most plants, the syndrome is they are hermaphrodite. They have both male and female flowers on the same bush. So here's an added complication to my survival chances. I'm susceptible to being browsed, and I also have a dioecious reproductive system, a male and female individuals, which means that if I get into a scenario where males are separated strongly from females at great distance, and the insects that take the pollen have to travel a long distance to take the pollen from the male to get it to the female flower on the female individual, fertilization rate will drop, seed set rates will drop, and again you can be on a pathway to losing your population. I just wanted to go to this one first. And here's the classic example from the Hawke's Bay. How many people have been to this location? Have you been there, Kate? On the Tuki River?
No, I'd like to go though.
Look at this. This is the Pittosporum occultatum Reserve. Right? You know what? I went there quite recently with some of the staff of the Regional Council to check it out, because this was a plant found way back in the 1970s, I think, by Tony Druce, and he wrote about it. And I wanted to go back, and I'd never been to this location, so I went to go and have a look. And of course I went to have a look, and it is a single Pittosporum occultatum, and it is a male. And there is nowhere for miles around a female. And so, you know, it was great that it was protected. But you know what the next step is? It's actually really simple. How about taking one female in there and planting them? And then you will no longer have the trouble of not being able to produce seed capsules and seed. Because just along from this location is a rather nice patch of Carcatia matai river flat forest, which is now being managed very effectively, that does not have Protospomop caudatum in it. So if you could protect the one here, add the female, and then take some of the progeny, you could translocate it back into the river flat forest very, very close by.
Sorry, where was the...
Where is that?
So it's called, I think it's called, is it Row Zoo?
Oh, right.
Yeah, I think it's a Row Road.
This is on the Tucky.
Tucky River.
Tucky.
Yeah.
Tucky? Yeah. So yeah, I did pass this information on to the regional council and I said, come on, what are we going to do about it?
Bruce, can you tell male and female plants apart when they're juvenile?
No, not when they're juvenile.
Yeah.
You have to wait until they flower.
So how would you know to plant, if you're planting a female in there or not?
It's a male, and I know that because if I go and look at it and I search for capsules and seed, so capsules are persistent on Protospomop caudatum, so they will stay on the plant for up to 3 to 4 years. So if there are no capsules on it, it's really simple to say, well, actually it's a male.
But to get your female that you're going to plant next to it, how would you go about that?
Well, I would go to a nearby location in the Hawke's Bay, and there are some, and I would find a female. And I would harvest the seed, and I think Marie Taylor is doing some of this already. Mari, is it Mari? Marie Taylor. She's doing this sort of stuff already, so you would find the closest location that's got a female, and you would harvest some capsules and grow some seed on, and then you could be into the game.
Yeah, but how long?
You wouldn't know that it's a female.
Find out it was a female, yeah.
So, sorry, what was that?
How long would you have to, how long before, you know, you might have to grow quite a big plant before you're going to know it's a female?
Yeah, so they actually, within 4 to 5 years, normally they will start producing the first flower. They won't produce many at first, but you will get a clue quite quickly. The other opportunity you could have, and some people have done this, you can grow this plant from cutting. So this might be one case where you might want to take the short circuit and grow a female from nearby by cutting, knowing that it's a female, and bring it back into the system.
Bruce, I've got 2 were given to me by the Gisborne Nursery, Native Plant Nursery, way back when they were gifted.
Mapapero
Yes.
Nursery.
Yeah, they were gifted. And I think they're both males.
Right.
Nothing much is doing. But Helen Jonas, Doc,
Yeah,
we've got 60 odd from Hurumua.
absolutely. I've
Yeah.
been there.
Yes.
Yeah.
And so I'm concerned now because they were eco-sourced from our precious little Hurumua reserve. I've got these 2 boys, I think they're boys, but I've planted all the rest quite away on the farm and in various locations. Is that going to create a problem in some way? These 2 are in my garden, it's a big garden, and they're in there. Have I got worries about...
Yeah, no, I'd be quite happy if you sort of kept between the Hawke's Bay and the southern Tairāwhiti. That's fine, because we have done genetic studies
Yes.
and morphological studies which show that that end of the distribution is so similar to each other
Right.
that it wouldn't matter.
Okay.
But if you had collected something from Kaitaia or Whangarei, I'd be really worried because the morphology and the growth form up there is quite different.
And last but not least, do you know what the real pollinator is? The actual
Have you ever been into the bush
in the beach?
at dusk? Have you ever been into a patch of bush with Protospomop caudatum and smelt the most remarkable fragrance? And have you seen the moths?
Oh, that's moths.
Originally, and this is originally, it was probably moths.
Right.
Nowadays, of course, it's largely honeybees. They are doing the job, though. They're doing the job. Yeah.
So Bruce, the male flowers too.
Yeah. So they both produce flowers, and the male flower is what we call functionally male. So it has female parts and male parts, but the female part, the stigma and the style, are non-functioning. And the reverse occurs in the female. So the female has a functional stamen, a stigma and style, and a non-functional stamen. So they are functionally male or functionally female, and occasionally they are inconstant. You know what that means?
No idea.
They change their gender. But they do it only on rare occasions. Yeah.
So you said earlier about growing seedlings 3 to 4 years before they'll flower.
Yeah.
When they do, can you then tell? It's male
Yeah,
or
I can
female?
tell just by putting them under a magnifying glass.
What if we haven't got you?
What's that?
What if we haven't got you? How can
No, you
we
can
tell?
do it. So, yeah, so you get the flower and you peel back the petals and you look to see the stamen, and is the stamen producing pollen? And you will know really quickly if it's not. And if it's not producing pollen, it's functionally going to be a female. It'll have a stubby ovary style and stigma. And if it's a male, it'll have a skinny style and stigma and ovary, because that's non-functional. And it will be producing lovely pollen. And you can see that really quite easily with a magnifying glass. And eventually, as you become practiced, you can actually walk up to the bush, and I can do this, I can walk up to the bush and just look at the flower from the outside, and it tends to be somewhat smaller than the female. The bush also tends to have more flowers on a male than on a female. And there's a lot of logic in that, isn't there? You know why that is? Because what it's trying to do is pump out the pollen and get the pollen spread as widely as possible.
And then you take a really good photo and send it to Bruce, because he'll be keen
Oh,
to
yeah. So I'm in big trouble now because I'm so obsessed with the Prospero that Tony's flashed the card at me.
So we've got about 300 or more growing in the nursery here, and they're going well, but listening to you now, we've got a problem of what do we do with them? And
Oh no, it's not a problem with what you do. We'll tell you what to do with them. You've got to get them back.
Put them out everywhere and hope that there's some male and some females.
Yeah, there's no problem with taking a chance on it. No problem at all, because you're still doing better than what's currently happening. Because, you know, wherever there is any light, you know, any grazing or whatever, they're not able to get, you know, if they're not properly fenced. So you'll still be helping the process. And when you've got numbers like that, your chances are, because in a natural population, the sex ratio is about 50-50 in a natural population. Yeah. So you've got a good chance that you'll get a decent population of males and females.
But Bruce, does that ratio also mean 50-50 when it comes to
No.
the seed development?
No, you don't need to worry, be too concerned. You don't need to have a nicely, perfectly balanced number.
No, but is there any sort of golden mean when it comes to ratio of Mother Nature, when it comes to...
Yeah, there is, but it's different for different species. So, you know, and it all comes down to what the comment I made before about sometimes you need more males. If the issue is pollen limitation, if the dispersal agent is present, it might, you know, you might need even more males. You see the point I'm making? So the ratio will be dependent on what's the situation you're trying to rectify.
Yeah.
And of course the reason that this is the exact reason why in small parts of catchments that some of these populations have failed, is you end up in a scenario where you have a very unbalanced sex ratio. So if you've got 9 females and only 1 male, or vice versa, and in some populations up in the Tairāwhiti, near Gisborne, you get a single sex represented, you know, you're down to the last 5 or 6 plants, you're in big trouble. And in this one, you're clearly in trouble. So I better keep moving, but I just wanted to come back to that little mold browsing hypothesis, and this is the other thing that we've been doing at Waikato, is trying to understand where does Ogcordatum fit in the Pittosporum story.
Yeah.
And of course, because there are non-divaricating Pittosporums and divaricating Pittosporums, but actually they hybridize quite easily. And so you know, the point is that you can build divarication into a plant, and you can actually create plants. You're just using the rules of nature. I'm not talking genetic modification here. You're just using the rules of nature, where if you take a divaricating shrub from a genus and cross it with a non-divaricating tree, you can create plants that start as divaricating shrubs and turn themselves into non-divaricating trees. So our flora is it's wonderful. And there's all sorts of stuff going on in there, and it clearly is an attribute that has occurred because divergence is not complete. They're still evolving, is what I'm saying. Some of our native plants are still evolving, and they have not, and hopefully will not continue. They've got to keep evolving because they're responding to different climatic conditions or different browsing regimes or whatever it is, and depending on the environmental situation, divarication could be an advantage or unnecessary in other environments, and that's what's driving this difference.
So Bruce, we don't worry about keeping these plants separate then? When we're doing a reconstruction, if they are together and they hybridize naturally, that's okay?
Yeah, that's fine, because if it's happening naturally, what tends to happen is gene flow will sort the issue out. So do you know the very common Coprosma hybrid that you see on the landscape, which is the halfway between Coprosma robusta and Coprosma propinqua?
Yeah.
That is a very common hybrid. And hybridization in Coprosma occurs really easily because the pollen is wind distributed. It doesn't need insects, it's wind pollination. And commonly hybrids spring up all over the place, but they don't persist on the landscape because gene flow means they keep back crossing to the original species, and they eventually come into equilibrium with their environment.
Okay, so we don't need to pluck them all out then?
You don't need to. I mean, the only ones that annoy me when I'm wandering around a city are all those strange pseudopanics things. Because the problem there is that because horticulturalists have got hold of the pseudopanics, some of them are hybrids to begin with. And then you get hybrids on hybrids, and you end up with hybrid swarms. And then in an urban setting, the gene flow can be in the wrong direction. So you end up with something that you didn't really want.
So isn't this a case then for being less concerned about eco-sourcing? Like here in Hawke's Bay, we have a terrible dilemma where we have very limited seed stock.
Yeah.
And so many of our natives have come from the Central Plateau with the Tamarana tree nursery over a 25-year period.
Yeah.
And so...
But nature will be sorting some of that out now.
Okay, so
and again, what I'm advocating for is eco-sorting is still important. But if you can't find it in the exact location, you start doing your research where you progressively look for the closest population.
So are you saying that eco-source could be as much as the whole of Hawke's Bay province?
In some species that's true, and there will be clues about that because there are morphological characters that you can see on the plant which will tell you whether or not you've got a particular ecotype or not. So I'll use a Waikato example. In the Waikato with Manuka, we have two main types of Manuka in the Waikato. We have the swamp form, which has very narrow leaves. This is genetically fixed. If you grow the swamp form alongside the hill form, which has broader, squatter leaves, and if you run the common garden experiment, they retain their difference. If you take the hill form in a restoration and plant it on the swamp margin, guess what? It doesn't do very well. So again, you've got to be using all of the observational clues and starting with your local area. Because of the limitations of available seed, you can move outwards somewhat, but you still have to keep an eye on what you're doing, because in that Manuka example, people have wasted huge amounts of time and money by planting the wrong Manuka ecotype in their restoration project. So it's not just for a purist reason, it's for the economics. And and the survival side. Mm.
How were the boundaries of the ecological districts come to originally?
How will they come to?
Yeah.
They were called, it was called the Delphi method. Have you ever heard of the Delphi method? Which is a Greek goddess, was it? I can't remember. The best botanical brains in New Zealand were assembled in various parts of New Zealand and asked to draw lines on maps. In other words, they used the synthesis of all of their observations and knowledge of the landscapes of New Zealand and put the lines on the map to try and put a natural regional basis, which was originally not just for ecosourcing, by the way. It was not designed originally for ecosourcing. It was designed as a way of carving up New Zealand for the Protected Natural Area program and to do it in meaningful natural units. But it does have a useful application for ecosourcing because they are natural boundaries that have been derived by people who really knew the landscape and the plants. So I'm a supporter of, with ecosourcing, your own ecological district, and then if you can't get it there, you go to the adjoining ecological district. But you've still got to keep your eye on ecotypic variation. I think we're just about there. Tony's going to haul me off the stage in a minute. There's that lovely architectural pattern. And there we are. There's the last slide. This is in memory of Phil Bendel. I don't know, have you ever heard of Phil Bendel?
Yeah.
A marvellous website comes out of New Plymouth, Taranaki, of native flora with the most amazing photographs. He passed away not too long ago. This is one of his classic photos. Okay, so